Okay, this video does the problem 48, and this time I'm going to solve for the acceleration. What I've done here in in black, is I've just copied over the solution that I had from the velocity. So if you look at that video or whatever, you'll see where this comes from. And so anyway, those are the velocity equations and the values that I got. In order to do the acceleration, with special points, what I recommend is that you mimic what you did for velocity. So you wrote one equation for the velocity of this. Okay, so you mimic what you did before. So before you wrote one velocity equation, and so you're going to write one acceleration equation. You're going to use the same 2 points that you used before. So that would be acceleration of A equals acceleration of O. Instead of omega cross, it's alpha cross R. We're using the simplification for the omega cross terms because it's two-dimensional. And then because there was some rel terms before, you're going to expect rel terms now. And so you have to add on these extra two terms for the rels. Okay, so if you plug values that you know in there, just like you did before, the acceleration of A has to be vertical because it's constrained to be in that slot. So I assume it's going to go up. That's why I put a positive sign in front of the A. If I solve for AA and get a positive number, I'm correct. It's accelerating up. Negative would mean it's coming down. And then you put in the values of angular acceleration. So that would be alpha, and it's positive k because it's heading in the counterclockwise direction. So it's positive alpha k. And then this R is the same R as it was before. So if you look on the video for the velocity, you'll have that. And then this is the omega that's given. And then this is the same R that it was in the velocity. So that gets you this middle term here. And then the last term is, or the next one is 2 omega. So it's positive omega k because the omega is in the counterclockwise direction, just like it was before. This term right here is the relative velocity that I got from before. So here was the vrel term, and this was vrel is what I called it, this term, and then it had the direction that was going out the value. So anyway, that's your vrel. You got that from the velocity term. And then you have another arel, and you do the same thing with it, right? What you do is you pretend like you're standing on the link. You look at the 2 points. O looks like it's not doing anything because it's stuck at the end of a rod that you're standing on. It doesn't appear that the rod's moving, and so O doesn't look like it's moving either. But this pin A might be doing something. It's either accelerating out the slot or it's accelerating in the slot. I don't know which one it is, so I'm going to assume it's going out the slot. So I don't know the magnitude, so I put it in as arel. But I'm assuming it's going to the right and up. In other words, I think it's going to accelerate out. When I solve for arel, a positive number means I'm right. Negative number means I'm wrong. Okay, so that's how you plug those things in. Then what I did was I just took this term right here, and I'm doing the cross product. So that's the red term here. So if you do the cross product, you'll get what's in the red. Then that I circled in the green here, this is the cross products that I'm doing here. So I just did the cross products. Now what I'm going to do is I'm going to gather up the I values. So on the left-hand side, I have no I, and that equals, and I'm going to pull off all the I terms. Okay, so I've got some in this red cross product, which is this much right here. So that becomes right there. Okay, then I have an I piece here, which comes in down here. And then I have an I piece in the green cross product, which is this piece right here. And that becomes right there. And then at the last, I have an A-rel. I've got some I terms in it, so cosine right there. And then I also pull off the J components. So on the left-hand side, I have AA. And then I'm going to pull off the J. So in the red cross product, I have a J piece. In the other term, omega squared R, I've got that piece. And then in the green cross product, I have a J piece. And in the A-rel term, I have a J piece. Okay, so those are my two equations. Then let's focus on the stuff that's in blue, the circled in blue. There's only one unknown there, it's A-rel, right? By the way, the unknowns are A-rel, right here, A-rel, and AA. So I have two unknowns and two equations. So I'm going to solve the blue stuff for A-rel. So I take A-rel cosine theta, and I take everything else and throw it to the other side. So I'm just basically copying here. And wherever I see an L, I'm putting in B over cosine theta. So this becomes alpha sine over cosine is the tangent, and then so for the second term it's a positive because I threw it to the other side. So it's omega squared. L is B over cosine, so cosine divided by cosine causes it to disappear. And then here I have 2 omega squared B. Sine over cosine is a tangent, and then L is B over cosine, so I get another tangent right there. Now if you just collect the terms up, you get A-rel then is equal to B over cosine theta, and then here's what's left over on the inside. Alright, so that's the A-rel term. Okay, so now let's try to focus on the red part. So AA equals, and I'm just going to substitute in L is equal to B over cosine, and so I end up with first term gives me this piece. The second term gives me this one because L is equal to B over cosine, so that's B tangent. And then this one gives me this value here. The two cosines cancel, if you notice up here. And then the L gives me a sine over cosine, or excuse me, B over cosine, so that becomes a tangent. And then the A-rel term gets a little complicated, but here's the A-rel. And the sine of theta gives me the sine when you factor out the L. The sine times the cosine here gives you a tangent, B tangent. And so then you've got these other rel terms there. Okay, so now let's just try to simplify. So what I did here is I just gathered up, everything's got a B, and so I factored out the B. And then I'm left with alpha, and there's an alpha here. So that's 1. And then there's another alpha right here. So there's a tangent squared. 1 plus tangent squared. And then for the omegas, you have, let's see, 2 omega squared right here. B omega squared, there's your 2 times the tangent of theta right here. Takes care of that term. This term, this middle term right here, is this piece. This guy comes from omega squared, right there, comes from here, omega squared tangent. And then you have 2 tangent cubes left over, so you have a tangent here times the tangent squared, there's 2 of them. So that term goes there. Okay, so now keep simplifying. So 1 plus the tangent squared is the secant squared. 2 omega squared, that's coming from here. 2 omega squared, you're going to factor out a tangent. 2 tangent omega squared, you factor that out. And what you're left with is a 1 here. These guys are gone. and a tangent cube becomes, factor out the tangent, so they get you another 1 plus tangent squared. Okay, so the last thing here, I guess, second to last, the b is right there. I'm just copying this one down, and then this is 1 plus tangent squared is the secant squared. And so now I just pull out a secant squared, and you're left with an alpha and a 2 omega squared from here, times the tangent of theta. So that's the final result. My advice is if you ever use symbols instead of numbers, if you did numbers, this one wouldn't be nearly so hard. So on an exam, if I gave you numbers, the algebra is much easier. Anyway, if you're using symbols, what I would do is I'd use Mathematica. So if you look at the video on the Mathematica, I explain how to use that on this particular problem. That's it.